Okay, so what this video is about the concept of diffraction. And, from your vocabulary terms, that diffraction is just talking about how a wave can bend if it's going through a small opening or around a corner. That's diffraction. So it's still a bending of waves like refraction, but we're not talking about any kind of new medium or anything like that here. It's just how it comes through an opening. Just to kind of recap, this diffraction that we see in some instances really does boil down to a type of interference pattern, as you'll see here in a little bit. So let's just recap interference. You can have constructive interference or you can have destructive interference. And this is what we're kind of talking about here. Remember, constructive interference is when a crest and a trough will add together, making something a lot bigger than what you end up having on either of the two waves. Here you have a crest meeting a trough and a trough meeting a crest, so everything just kind of cancels out. You can remember have anything really in between. This is completely constructive, this is completely destructive, but it's possible that you might not completely cancel out or completely reinforce. Just a reminder that you can pause or roll it back anytime. So diffraction happens with any kind of wave. It happens with light waves, it happens with sound waves, it happens with water waves. And this is actually a picture of water waves coming through this opening. And you can see how the water waves coming in are relatively straight. They're coming in kind of at an angle to that opening, kind of coming in like this. But what happens when it gets to the opening? All of a sudden you end up with these bends as it comes out. Okay, what's happening here? Why is it doing that? Well, when you get to a corner like this, and the wave's coming in, especially if the wave is coming in, straight at the opening, then you wouldn't expect to have waves just, and I want to do this in red, you wouldn't expect to have the waves just where the opening was, would you? That would be really weird, because what would happen at this boundary right here? You would have part of the water being above the other part if you had waves just coming out. So the red stuff is not a good way of describing what a wave does. Okay, as soon as it comes to the opening, the water molecules with the surface tension at the end, things like that, and it happens the same with sound or light, will affect the molecules right beyond the opening. And it's going to affect this molecule, which then propagates out in this way right here. Same with over here. So as a straight wave comes in, you shouldn't expect it to just go straight through the opening. Now you can say, well, if I have a beam of light or a flashlight or something that I'm shining on this slit, here's my flashlight, and the flashlights go out like this, and there's a slit right here. Then what do you see? You see here and here, right? You see this um, little slit of light right here. Okay. Well, it's not exactly just from the boundary, and I can convince you that if you ever go outside and take a look at your shadow. Does your shadow have clean boundaries? Is it just a clean light to dark boundary between you and the shadow? And next time you go take a look, you'll see that it's actually kind of fuzzy. And the same thing here. It'll be kind of fuzzy here on the ends of the little light beam here, and that's because some of the light that's coming through is actually bending outward. Okay, and that is diffraction. So it happens with light as well. So here's a little animation, kind of showing you what's going on. Okay, if the animation is going to go. Okay, I'll make sure to post these notes. That way you can go back and take a look at the animation. Let me run it back and see. There we go. Okay, well, go on a little bit. So you can see how all of a sudden you end up with uh, this bending of the wave as it comes out. Now you might be able to pick up, if you look at it hard enough, that obviously we have some really bright waves coming out, just going straight out, okay? And they're bright, and I'm going to call them bright because maybe this is light waves, or maybe it's sound waves, so it'd be really loud. And this is going to be, you have areas of constructive interference. But you might see, I'm going to do this in blue, that there seems to be these areas where you all of a sudden don't have any kind of wave whatsoever. Okay, and those areas are going to be something that you uh, end up having with destructive interference. There we go. Okay, we have destructive interference coming out with these waves along here. Okay, and when you have destructive interference with light, it means you don't see a thing. If you have destructive interference with sound, it means you don't hear anything. So let's say this is light. Let's say this is light, and if this is like a flashlight coming in, and I put a screen right here, right through the side of it. Let me draw it off here, maybe. Okay, what if I put a screen right there? What would happen? Well, you should be able to tell me that there's going to be a really bright spot right here where most of the light's just coming through. But take a look over here. Some of the light's going to hit right here. Some of the light's going to hit over here. Some light's going to hit over here, and some light's going to hit over here. And there looks to be areas where you have destructive interference with the light, so there shouldn't be any kind of bright spot. So if we did this, then what we would actually see, and I'm going to kind of skip through this, is something like this. Okay, where you have a really bright spot. This is kind of a graph of intensity. You have a really bright spot right here in the middle, but then you have these little bright spots on either side, and you can actually have a lot of little bright spots. Now, what's the reason for this? Well, it's because of the constructive interference that we're talking about. If you take a look at it, then you can have a piece of light, a light ray coming from this edge of the boundary, and it's got to travel some distance. Okay, there's a distance, d. Okay, well, a piece of light or a light ray from this side is going to have to go to the same point, if it does go to the same point, and it travels that distance, and maybe that's, we'll call that d prime. Okay, but d prime is obviously bigger than d. D prime bigger than d. By how much? Well, it's bigger than d by exactly this little amount right here that I'm going to circle in green. Okay, that's how much d prime is bigger than d, by that little small amount. Well, if that extra distance that the light has to travel, that's going to make the waves get off from each other. But if we can make sure that that extra distance is actually one full wavelength, then we can still have constructive interference here. Okay, and it just means that they're offset a little bit, but it just means that you still have crest and crest and trough and trough. Okay, similarly with the dark spots here, that's going to be where that path difference is going to be a half a wavelength, where you have destructive interference. So what would this look like? It would look like this. Okay, so if you have just this single slit, we call it single slit diffraction, you shine a light on it, then you're actually going to get something that looks like this. It's not going to be just a single band of light where the slit is. You're actually going to get these smaller constructive areas and the bands of black where you have destructive interference. Seems a little weird, but this is what light does. It's a wave, so it can interfere. Okay, now what happens if we have two slits? So this is like having two different sources, right? It's basically we have diffraction, just regular good old-fashioned diffraction coming from this slit, and regular good old-fashioned diffraction coming from this slit. And when that happens, then it looks like you have two waves, maybe in water, it could be water waves, but we're saying that this is light, where you have these two waves that are interfering with each other. Take a look at how the pattern's coming out. Okay, the pattern's coming out where they are actually interfering with each other. Now you might be able to see that there are areas where the waves completely cancel out. Okay, I can't draw on the animation, but see where those arrows are. You have an area where the wave completely cancels out. There's no waves going on right here. So this is going to be an area where we have destructive interference. Okay, there's our destructive. Then we can have areas where we have constructive interference. So this is the same thing if we just had one single slit. It's just now we have two slits that are acting as two different sources. Now you guys experienced this in the classroom whenever I had the two speakers going. I had the two speakers that were both playing the exact same frequency, and you guys walked around and you found areas where you had destructive interference and areas where you had constructive interference. Okay? Areas where it was loud and areas where it was soft. Same thing with light is that you can have areas where it's bright and areas where it's dark. So what would that look like if we have it on a screen? Well, I'll get to it here in a second. This is basically an animation that shows what is happening. So I can get it to play. There we go. So we have these two sources, S1 and S2, and the bold lines are crests, the thin lines are troughs. And take a look, where all these red dots are, that's where you have a crest and a crest and a trough and a trough. Okay, this looks very similar to what the animation was showing us in the last slide, where you have these bands, these lines of constructive and destructive. So take a look at the blue. The blue is where you have a crest and a trough. So the blue is going to be where you have destructive interference. So you'll have constructive and destructive interference in these rays basically coming out from where the two slits are, like right basically between where the two slits are. Okay, so you have these bands of constructive And then here in a second, it's going to show you the bands of destructive again. So there's the blue, there's bands of destructive. So again, what would happen if I took a screen, maybe this is light, I took a screen and I just put it across the top. Okay, what would it look like? Well, it actually would look more like this. It looks very similar to the single slit diffraction, the single slit interference pattern, where you had one really bright band in the center and it decreased as it went down. With the double slits, because it basically looks like two sources, you have less of a decrease in intensity as you get further away. So this interference is more like this. Now, we've actually already seen this one time before in class whenever I showed the laser beam onto the CD and the DVD. Okay, we had some diffraction patterns coming off from that, and that's exactly how a computer reads what's on a CD or DVD. Okay, it uses the diffraction pattern coming off from the laser beam that it's shooting at the spinning disc. Okay, I'm not going to go into that. So this is diffraction. If you have any questions, let me know.